Now coming to the third theorem, the theorem is if a function f from a to b, a function g from b to c and a function h from c to d are functions, then HOGOF and HOGOF are possible or not. We can find the result, are they equal or not. Very simple thing. Again, let me tell you about the notation what we are doing. GOF, it means what? Function f is applied first and then function g is applied second. So here again you can go through the theorem that if a function from a to b is f, from b to c is small g, from h to d is h. Now we are having three functions, 1, 2 and 3. Then how they are correlated, how they are equal. Now how we can write this left hand side? Now our left hand side is, now for the left hand side we are having h of g of f is equal to, now like this one. Okay. Now this whole function, first of all I am solving only this part, then with this one is equal to h g of fx, this is equal to h, and now for this one goes to this part, I have first solved this one, that is this one, and the combined result of this is this one. So here how it is, this is for all values of x where x belongs to I. Now this symbol is for all values, this symbol is for all values, we are writing for all values. Now for the right hand side, we are having HOG f of x. Now this becomes what? Fx is equal to h g fx. So you can see that both the right hand side and left hand side are equal where x belongs to a. So easily if we are combining three functions, now suppose we are having first function is 1 1, means first two functions a and b are 1 1, b and c are 1 1, c and d are also 1 1, then it means a to d is also 1 1. A very simple theorem. Now we are going for a next theorem, that is invertible theorem, because what we did, first of all we did 1 1 function, algorithm approach was 1 1 function, then on to function, then if a function is 1 1 and on to both, then we are having the inverse function. Now similarly we have to prove the theorem part for the inverse also, so we are going to do it, and little bit these things, because there is no calculation part makes a lesson very interesting. So after doing this part we are moving to the calculation part, and indeed that will be a interesting one. So invertible function related with the composite part. Now first of all just move with the definition. A function f from a to b is said to be invertible if there exists a function that is, another function is g from b to c such that combined function, now composite function a combined form, and FOG is equal to IB. You can go through the invertible function, a definition part. Now here then function g is called the inverse of f and is denoted by, you are all aware of the symbol, is denoted by f inverse. So G is equal to f inverse. Now this is a nice definition, and after this one I am just in the next theorem I am going to prove this one how it is possible. Okay.